(0.02560 liters. Okay. So the question is written out for you here, but I'm actually going to solve it over here so that we can look at how we would attack a problem like this. So remember the two things you need to do. Firstly, you need to change molar to moles per liter. And the second thing you need to do is you need to change milliliters into liters. So let's do that. Our 600 milliliters becomes how many liters? Everyone. 1, 2, 3, 0.6. And don't forget, you've got 1, 2, 3 significant zeros, so we need to have our 1, 2, 3 significant zeros. Okay, that's liters. And we have a 1.55 molar, so that's going to become 1.55 moles per liter. And you know what's really fun? Do you guys know what of means? Of means times. Yeah? And this is going to become convenient later on when you start getting a whole bunch of different volumes and concentrations in a question, because later on we'll have two substances reacting together. So it's always nice to say, oh, look, of means time. So if you're ever given a volume of a concentration of solution. Hi.
So sorry to interrupt.
No worries.
I don't even know what they're called. Is that deep powder funnel?
Yes. They're on the top shelf.
Beautiful. Thank you. I remembered that.
Yeah. All good. I think it might be both of them.
I appreciate that.
Cool. No problemo. You can even cut through like here and it's faster. Okay. All right. And that's it. So we then go, okay, we chug that into our calculator. .6 times 1.55 equals, liters cancel, and we're left with moles, 0.93 moles. Is good? Okay. How many moles of KBr would you need to make 250 milliliters? What's that in liters? 0.250 liters of an 0.150 mole per liter solution of KBr. I'm not even going to bother solving that one. I don't know why I have two examples that are the same. That irritates me. But there we go. And the only thing is here, we do have to be careful about our sig figs. 0.15 times 0.25 is 0.0375. How many sig figs should we have in our answer? Tell your partner. Why did I get rid of that 0? Because there is no decimal there. Okay. However, if you were to make an assumption, I try to always put a decimal there, like on a test or whatever, because I don't want to have that ambiguity. Because if you say 250 milliliters, is it really reasonable that we're out by 10 milliliters? Like, it doesn't sound particularly reasonable to me. We probably used a 250 milliliter graduated cylinder or something. Yes. So I'm not going to get too worried about that, but there we are. Okay. Now, do I have any other things here? Oh, here we go. Okay, so there's some practice exercises. And now we do have some questions going the other way on page 60. What volume of 1.25 molar CaSO4 would contain 5 moles of CaSO4? Tell your partner what the first thing is you should do with this question. Do you guys want to try and see if you can do it? Try it. If you're not sure where to start, show your partner. Do you like my answer? No. What's wrong with my answer? 0.0, we need to have 2 sig figs. Yes? Cool. Now, sometimes people want to write you can do it this way. They'll do like, they get a little confused and they're like, oh, 1.25 moles per liter times, right? And then they get stuck. Yes? Because, if you start with that, now you've got moles on the top, your liters are on the bottom, so that's going to be problematic because we want to have liters on the top. So if you did want to start with this number, you would have to say, I have 1 liter, so that the liters are on the top, per 1.25 moles, and then I could multiply that by the 5.0 moles. But that's the most common way that people go wrong, is they tried starting with this number and it leads them down the wrong path. Yeah? So just remember, molarity is the conversion factor. Okay, so it comes where the conversion factor goes. All right, how many milliliters of 3.0 molar NaOH can be prepared from 0.15 moles of NaOH? Do you want to try that one? So this is on your next page, I think, from the one you were just on. Feel free to check your answer up here when you're done.
Why does the example say 50 points?
Oh, why does it say 50 point?
Why?
We have 2 sig figs here, and we have 2 sig figs here. Oh.
Oh, okay.
Better?
Okay.
Cool. I was just being careless. No, you should get the same. Yeah. That was just me being careless. Is good? Yes. Either of these is okay. 5.0 times 10 to the 1 or 50 point. Yeah? Cool. Okay, let's see if that was it for this. So we had that. There's some practice exercises. Is there anything else? No. So let's see what 5.3c has in store for us. Ooh, molarity, grams, and particles. So your choice as to whether you do 5.3b, okay? You have a choice as to whether to do 5.3b. And here you're going to, now we have a new area of our map. Yes, we've added that little up thing there. Okay. So we have from moles, and I really want to go through and change all of these little maps to the other map because I like the other map better. It's cleaner. So if we were here, where is it? Did I put it here? Oh. There we go. There we go. Okay. So if I clean this up, we are now able to do everything that is highlighted. Okay. And there are 1 or 2 of you, not a whole lot, who should probably work on just memorizing this until it becomes like second nature. Yes? I finished marking your quizzes, by the way. So mostly good. Like I said, there's a few people who should just memorize because I did have a few people trying to go directly from grams to molecules. And you can't do that in 1 step. You have to do that in 2 steps. You can see it, but not right now. Okay, we'll see it at the end of class. So 5 minutes before the end of class, remind me. Okay. So this is what we know. This is what we now know. All right. And like I said, feel free to have this out in front of you while you're doing the problems, but try not to use it until you need to. Try and see what you can do without it, And then if you need to, you can sneak a little look, right? Okay. Okay, back here. Oh, where'd you go? You see. So again, I'm not going to, we're not going to spend time doing this. Okay, I'll give you maybe a little bit of time at the end of class to work on it.
So
all right.
5.3.
5.3c is homework. 5.3b is optional. Okay, because if you find 5.3c too easy, then don't do it. Yeah? But if you're like, you know what, that confused me a little bit, do 5.3c first. Yes? And for 5.3, why don't you just do the odd numbers? Yeah? So you're not doing too many? Huh? Oh, B and C.
There's no D.
No, there's no D. So we're good, right? This is correct now? Good, 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 good. Okay. Ooh, yeah, I like number 9. Number 9 is cool. Okay. Now, we are going to go to 5.4a, density, mass, and volume. And this is on page 65. Page 65. In the pink one. There we go. All right, so we have mass. Do you guys all know the definition of mass? Tell your partner, don't look at your book. What is the definition of mass? Dylan and Stephen, you guys need to talk more. And if you finish talking about mass, you're going to talk about what is volume and what is density. Don't look at the book. Alrighty, mass is the quantity of matter in an object. Volume is the amount of space occupied by an object. And density is the mass contained in a given volume. Okay? So if you want to find density, you have to do a division. Okay? Now, we get so caught up in converting things that we sometimes forget that sometimes we don't have to convert something. Sometimes we have to do a division. So 2 things where you have to do a division. One of them is to find the density. Let's pop back here. Is this the one? Nope. Is that the one? No. What is wrong with me? There we go. Oh, look at this. Down at the bottom of our mole chart, we have molarity. Molarity is a division. So if you actually need to find the concentration, you're going to do a division, moles divided by liters. If you want to find the density, you have to do a division. There's no conversion factors here, okay? Unless I'm having you convert density in grams per liter into density in milligrams per milliliter or something like that. Do you know what I mean? Okay, so finding density is not a conversion. Finding molarity is not a conversion. Both of those are divisions. Use lowercase m for mass. Be sure to use capital V for volume. And you can write it as a lowercase d. You can write it as an uppercase D. I actually don't know what the real one is. Actually, I do. It's really the Greek letter rho.
Yeah.
Okay, but that everyone, when they start writing that, they think they make it look like a P. And so they'll write it like this, and that's not a rho, that's a P.
You start at the bottom.
Yeah, you start at the bottom and you kind of go up and you don't quite attach it or something like that. Okay, but D works very nicely for density. Okay, so just go with it. You can use a capital D, lowercase, I don't care. So if we have an iron bar that has a mass of 19,600 grams and a volume of 2.50 liters, what is iron's density? To show your work completely, you should do the following things. So this is, I don't imagine you'll have any problem with this question, but make sure you do these things. You're going to write the formula, density equals mass over volume. Then you're going to plug in the values with the units.
Yeah, you can give them molarity then.
Yes. Okay.
So the molarity or even.
Now molarity becomes a bit of a dodgier thing because it's like so
Weird. Yeah.
it's such a common calculation that will often just go concentration of this equals this many moles over this many liters and be done.
Do we have to write them?
No,
Okay.
I don't think so. For molarity, for density, you should, because it's going to get you in the habit of writing the formula for when we have something like PV equals nRT. Yeah? And for those ones, I know for sure that AP really wants you to write the formula. Yeah? Whereas molarity is sort of like a basic skill that they're like, oh, everybody knows how to calculate molarity. And then you'll do the division and you'll get that. Now, if it were me, I would not write this in 3 steps. Okay, I would write it all in one line, D equals M over V equals, and I would plug in the values in the units, and then I would get my final answer and I would box it. Is good? One other comment I'd like to make for people writing their quiz. Anytime you can make your work more efficient by writing it all in one line rather than writing it in several lines, do that. Because I noticed some people who were finishing a little bit later showed extra steps along the way. And one of the things about the AP exam is that you will be tight on time. So you don't want to spend too much time writing things down that you don't need to write down. Okay? There will be a note on your page if that has applied to you. Okay? Density can be used as a conversion factor. We have a density here. How should we rewrite that for it to look like a normal conversion factor? Tell your partner.
Just for this.
So you'll just rewrite it so one's on top of the other. You don't have to do it before you do the question, but in the question, you don't want to be writing it as grams per liter like that, because then it becomes hard to see what's on the top and what's on the bottom, okay? So we want to find the volume in milliliters that is occupied by mercury. Do you guys want to try that one? I know you have the answer in front of you, but do you want to like get yourself a piece of paper or something and try it out? If you need paper, there's blank paper at the back of the room. Is good? Okay. Now, you can use the density formula to solve this problem, but I find people are more likely to make a mistake using the density formula because they'll solve the equation wrong or they'll put things in the wrong. I don't know. I don't know why they make mistakes, but they tend to make more mistakes. So you would need to take your equation and solve for V. You don't need to write this step, but you would need to write this step. I usually write down my original formula as well. That way I don't make a mistake. Yeah? So I would write down, so this would be number 1, this would be number 2. And then at that point, you can plug things in. Now, how did we solve for getting V on the top? There's very, very many different ways of solving it. I mean, this is for my regular 11s who might not be able to do algebra so well. Are you guys good with algebra? Okay, and if you're not good with algebra, then just use the conversion factor, because then you don't need to worry about rearranging it. And we'll talk algebra when we get to the ideal gas law. Okay? Now, if you do use density equals mass over volume, solve for V, you do have to make sure that you plug in the units. Okay? So this is another reason why I am not in love with this method, because it just becomes a little uglier. Yeah? So what happens here is that I have grams over grams. So my grams cancel. Yes? That leaves me with a 1 up here and a 1 down here. So what I now have, this bizarre looking piece of stuff is now 1 over liters, which is the reciprocal of 1 over liters, which is liters. Okay? The other way of doing it is to say I have grams over grams per liter. If I divide by something, that is the same as multiplying by its reciprocal. Dividing by something is the same as multiplying by its reciprocal. So I can get my unit that way as well. Okay, my grams cancel out and I end up with liters. Or if that all makes you like a little bit dizzy, you can be like, I know my volume has to be in liters, and you can just not worry about it and just say, it will work out to be liters. That always makes me a little uncomfortable because I always like to know that my units are working correctly. But, you know, with something this simple, it's probably okay. Yeah? So you don't have to do any of that fancy stuff. You can, as long as you have written your units in here, you can just go straight from here in green over to here. Yeah? And then you would have to do the final conversion into milliliters. And you can do that by moving your decimal. You can do that by multiplying by 10 to the 3 milliliters per liter, or by 1,000 milliliters per liter, whichever conversion factor you like. Okay? Oh, and look, it says dividing by a fraction is the same as multiplying by its reciprocal. It's just a handy piece of math to know for chemistry and all physics and all sorts of things. Okay? But like I said, my favorite way of doing those conversions is to use density as a conversion factor. And if we go back to our table here, our chart, look what we have. We have density as a conversion factor, and it allows us to convert between volume of A into grams of A. Now, watch out. We have several volumes on this chart. We have volume of a solution. Yes. We have volume of a solid, liquid, or gas. So basically, if it's not a solution, use density, unless it is a gas. We'll look at that. I don't know if we'll get to that today. Unless it's a gas, in which case we'll learn the conversion factor there. There's a straightforward conversion factor there as well. Okay, so if you're not given the density and it's a gas, you will use this one down at the bottom that we haven't learned yet. But for now, that's enough volumes to deal with in one go. Okay, let's not introduce 3 volumes all at once. That might go a little crazy. But that's where we go. Okay, and you have to be given the density in the question. Okay? If you're not given the density in a question, maybe it's a solution and you should check for the molarity. Or maybe it will be a gas and you'll check for to see if it's a gas. Okay? Where did we get to? Okay. Well, okay, so here's some questions on that. Density in moles. Page 71. So if we look at our question, who is the thing we will be starting with? What will we be starting with? Will we be starting with our density, or will we be starting with milliliters? Tell your partner. Which one is your initial quantity and which one is a conversion factor? Milliliters is the initial quantity and density is the conversion factor. And what that's going to allow us to do, that conversion factor is going to allow us to convert from milliliters into what? Grams. And if we have grams, are we able to find moles? Yes, and that's a conversion that you should be familiar with. What do we use for that? To go from grams to moles, we use the molar mass.
And then we might go down.
Right, so here we go. Let's do it. How many moles do we have if we have 23.0 milliliters? So we need to cancel the milliliters and find the grams, 0.789. And then we need to cancel the grams and find the moles. And I have 24 plus 6 plus 16 is 46. Here's another one. Mass of carbon is 12.0. Mass of hydrogen is 1.0. Oxygen is 16.0. What do they all end in? They all end in 0.0. So would it be okay for me to write 46 grams? No, because remember, I'm adding them up, so I have to put a 0.0 there. Okay? And we need to have 3 sig figs, so that becomes 0.395 moles. Is good? Okay. What else have we got over here? Let's see. Molecules. Super fun. Yes. Oh, we could do that. That would be even more fun. But we're gonna just save some of our fun for later. Okay. Could you guys do this one? That should say degrees Celsius. I need to fix that. And if you're like, I don't know how to solve this, what the heck? Well, we're going to look and we're going to say, I have milliliters and I want to get to molecules. So I'm starting with milliliters and I have a density. So I could go to my sheet here and I could say I have milliliters. That's what I'm starting with. And I want to get to molecules. That's going to be over here. So that's going to be a 1, 2, 3-step process. And I'm going to use the density as a conversion factor, the molar mass, and then Avogadro's number to get from milliliters over to molecules. Okay? And because I haven't spent a lot of time showing you guys how to do this really efficiently, I'm going to spend a moment doing that today. So I'm going to say I want to go from milliliters to grams. So I need to cancel my milliliters and find my grams. I will often go through and just write my conversion factors with no numbers and put the numbers in later. Then I know I want to go from grams to moles. So I cancel my grams and I find my moles. And then finally, I want to go from moles to molecules. So I'm going to cancel my moles and find my molecules. And then I say, oh, grams per milliliter, that's given in the question, 1.00 grams per milliliter. Grams per mole, that's my molar mass. And I've got H2O. And it is really handy because we use water so often to just know the molar mass of hydrogen. Not that it's hard to find. You have a 1.0, 1.0, and a 16.0, so that's 18. But sometimes it's just nice to know that one by heart because we use water all the freaking time. And in order to convert between particles and moles, we use Avogadro's number. And I'm so happy none of you on the quiz did 6.02 times 10 to the 23 moles per 1 molecule. That made me so happy that I did not see that anywhere. Oh, I also noticed there's quite a number of people writing this. Or something along these lines. That is wasted effort. Yes? You already have that written down. You just do this part on your calculator. Okay? Not that it's wrong if you do that, but if you want to speed up your work a little bit, you'll just get rid of this. Okay? It's not wrong to do it. It just speeds you up a little bit if you don't write that step. You don't need to, right? It's not required. So just, like, if you like it, if it helps you get the right answer, I will not argue with you. But if it's not particularly helpful to you, then don't do it because it wastes time. Yeah? 2.56 divided by 18 times 6.02 E23 equals 8 point. Let's see, we got 3 sig figs and 3 sig figs and 3 sig figs and 3 sig. Oh, 3. Oh. Would we like to go through the next 2 examples?
Try some more.
Try some more yourselves? Sure. So what you can do is you can get yourself a piece of paper and cover up the answer to this. Okay? And if you're feeling unsure, yeah, for sure. If you're feeling unsure, you can watch me kind of slowly poke my way through it up here. Okay, so if you're like, I don't know, how would I start?
and then using the density to get the point. Also, the expense.
Yeah.
For a volume matter, like,
No, if it says volume, you get to pick. If it says volume in milliliters, then give it in milliliters. But if it just says volume, you choose what unit you want. So say for example, in this question, I would choose centimeters cubed because that is what is given to me and I don't have to do extra conversions. Yep.
It looks funny.
Oh, one last thing that I noticed on the quiz is I have some people who are liking to use this notation instead of that notation. I think it is just clearer if you use that, because that can sometimes get mistaken for a decimal, depending on how tidy your writing is. Yes? So if you have a tendency to use that in the scientific notation part, maybe try to switch over to times. I don't know. It's not hugely important, but clarity is always good.
You're right, like that in my.
In what?
My French.
And you know what? If you're used to it and it's a thing, then just go with it. You know what I mean? Like, it's not like I can't figure it out. I always just think, what if the AP marker is like, you know, tired or sick or stupid, or, you know what I mean? Like, yeah. Anyway, I can figure it out. I can also figure out commas instead of decimals because I know that's a European thing often as well. I would say maybe try to transition to decimals if you're writing an AP exam. I think they know as well. I think they're probably smart people and can sort it. But, you know, I don't know. I just don't know how important it is. Do you know what I mean? I can sort it out. So I have no issue with it. But
Sometimes write like that, just like.
Yeah.
Just write.
you just write what you're used to. Yeah.
Different thing depends on like.
Oh my god, 6.2 is
Yeah. Well, and another way of doing it is 2.6 e negative 22. Yeah. So you can do that as well.
It's like slightly different number.
So if you were doing this example, it is worked up here now.
I think it's 6.2.
Yes. Did I do something wrong? Oh, I didn't write grams. Oh, I need to go to volume. Totally forgot. Whoopsie. I got carried away with my times thing and yeah, totally forgot about it. You guys are lucky, actually. For the most part, the workbooks that you're getting have been through like at least 2 classes already. Because when a workbook first comes out, the answer key is littered with mistakes. Because you see, like, how many mistakes have I made this class already? Like 17,000? Like, I don't know, if you watch me working through it, I'm like, liters. Oh, no, I meant moles. Whoa. Right? What? This is the example on middle of page 72.
I think that answer key is a.
Oh, that's very likely. Where? Which one?
Yeah, this was supposed to be 22.
Okay, so that's the example on page 72. Let me actually, you know what? If I put it on here, this is actually better. Page 72. Because I go through this later and I look for my big stars. So I fix things.
And this is supposed to be 260.
Ah, yes.
It's
Yes,
the
yes.
one I just did, but I think
Yeah.
you have like a mistake.
A wrong answer here. Okay, so this should be what? Like,
No, I think this is
this is right? This is wrong?
Yeah, I think so. 'Cause
9.9 times 10 to the negative 23?
I don't think that.
No, that sounds wrong. Oh yeah, no, I've done something really wrong here.
Yeah.
Okay, 1.8 times 10 to the 24 divided by 6.02 E23 times 87.6 divided by 2.64 equals 99. Is that right?
Yeah.
Cool. Okay. The answer should be 99. I don't know where this 23 came from. I don't know what I was doing. I'm so sorry. The answer key is right, except for that it had 3 sig figs instead of 2 sig figs. Why are there only 2 sig figs in this one? Because of the 1.8 times 10 to the 24?
Oh.
It's wrong. The one above it should have 3 sig figs. Yeah? So this one here should be 99, not 99.2.
So now it's convergent.
Yeah. There we go.
I'm not gonna be here on Monday.
Okay.
What do you think we're gonna do?
We are going to cover electronegativity just a little bit because that's what I did with my other block. And then I have to cover like coulombic attraction with them. And then we're going to be carrying on through our workbook, which is where did I put it? Here you are. I imagine we will get to molar mass of an unknown substance and molar volume and maybe into gases. Okay, so we'll be working our way through here somewhere in there. Okay? Yeah. All right, lovelies, would you like to take a look at your quiz?
Yes.
The only thing is, Victoria, because you're sitting beside someone who hasn't written it, you just need to look at it and then give it, or just look at it elsewhere and then put it in your bag, okay? Please do not share it with anyone who has not yet written the quiz. All right, when you hear your name, come get your quiz. Dylan. And I'll turn off this light thing here so that we don't go blind. Okay. Malvika. Audrey. Kara. Sylvia. Juno. Stephen. Karshika. Jihan. Victoria. Ira. Sasha.
Oh.
Samantha.
Oh, my name.
No, not yet. Katie.
Ryan is asking for the diameter,
Vera.
not the radius. You started.
Imran. Tiago. Helena. Pardon me, you get to keep it. Yeah. Brian. Claire. Ruslana. Brian? No worries.
So I think my
Hanno. Tony. Juan. Senya. Tony. Okay. Did I miss anybody? Everybody got it back? Good stuff.
You.
Try harder next time. Come on.
Yeah. Stop.
And don't worry if you made stupid mistakes, they'll be taken care of by the scaling. Okay? Quizzes are meant for you to learn from. Homework's up here, 5.3b, optional 5.3c, odd numbers, 5.4a, optional 5.4b, odd numbers. If you want to do them all, you can do them all, but odd should be good enough, I would think.